Hello, everybody. I apologize for being absent. I know kind of crazy to be gone the day after break just starts. No, I'm not sick of you yet. I just had to go to a meeting thing all day at Alec Tech. Um, yeah, so unfortunately I can't be there, but luckily with the power of technology, we can still be here in spirit anyway. Um, just gonna quickly, or try it as quickly as I can, because you know me, I get long-winded. Try and cover section 5.4 here, or at least finish it off. Yesterday we did factoring. We did some factoring. We factored cubes, and we factored by grouping. So again, that was yesterday. We did that. Today, we're factoring look-alike quadratics, and then we're solving. Um, that's a K. Yeah, there we go. Look-alike quadratics, and we are solving them. So, solving polynomials, I should say. So, before we do the look-alike quadratics, just want to quickly run through an example of what of what quadratics look like. So, we remember solving something like this, or factoring this, I mean. Now, there's no number in front, so we automatically go to the parentheses like this. Hopefully this reminds you of something you know, either ninth grade or 8th grade or earlier this year when we did quadratics. So we look at this last number. Ooh, stripes. This last number, we want two numbers that multiply to be this. Oops, I need it. There we go. Multiply to be this, and add to be the middle number. So we want two numbers that multiply to be 6 and add to be 7. We think two numbers that multiply to be 6. Well, you can try 3 and 2. 3 and 2 add to 5. That's not what we want here. 6 and 1 add to be 7. So we're going to put a plus 6 and a plus 1. So this is our factored out answer. Again, we're breaking up. Like I talked about yesterday, you know, we're the home wreckers. We're whatever. We're breaking this up into pieces. We're smashing a big rock into little pieces. That's our big idea here with what we're doing. So that's just a reminder. And then what we're doing here today is a little bit more complicated but very similar. So here are our first examples. Again, this is factoring look-alike polynomials, look-alike quadratics. So this isn't a quadratic because it has a fourth power here, but it's like a quadratic because there's three things and there's nothing in front. So we're going to go like this. This time we're going to have an x squared in front. Now we have an x squared in front because our middle term has an x squared. Just like on our example back here, our middle term had an x, so we put an x in front of each parentheses. Here our middle term is an x squared, so we're going to have an x squared at the front of each parentheses. Now we think to ourselves, we want two numbers that multiply to be 45, and two numbers that add to be negative 14. So think through our head. 45, negative 15, and negative 3. Nope, they add to be negative 18. Negative 9 and negative 5. Those add to be negative 14, so those are going to be the final parts of our answer here. Now, we're not done yet. I quickly went over this yesterday too, but if you can take the square root and it's a minus, this is called a difference of squares, then we want to break this up into x plus 3 and x minus 3. 5 is not a perfect square. The square root of 5 is not a nice number. It's 2 point something something something. I don't even know. So we leave that one be because we can't break it up into nice numbers. So this is our final answer for the problem. We took this bigger polynomial, we broke it up into small pieces. We'll see why that's important on the next screen. So, okay, one more problem I want to show you. Oops, went a little too far there. Here's another one. Yikes! 7th power. Oh my gosh, we've never done exponents that big before. So we look at it and can we take anything out? That's always our first question, and I didn't really talk about that on the first example here, but um, can we take something out? That's always our first question. So we look at this. We can divide each by 3, so that's going to go in front. They each all have at least y to the third, so we can take that out. So we're left with y to the fourth minus 5y squared plus 6. So we factor everything out we can first, then we look at what's left and we think, can we factor this? This is another lookalike quadratic. There's a y squared in the middle, so we're going to do that. We break it up into the y squareds like this. Now we look at the plus 6. We want two numbers that multiply to be plus 6, add to be negative 5. So we think to ourselves, two numbers that multiply to be positive 6, add to be negative 5. Negative 3 and 2, negative 6 and 1. Those are our choices, the negative 1. Those are our choices. This adds to negative 7, this adds to negative 5, so these are going to be our fill-ins, negative 3, negative 2. Our last thing to check, so, again, going through the steps, first we take out anything we can from everything. Next, we break up the thing in parentheses. Lastly, we say, can we take the square root of this? Is it a nice number? No, the square root of 2 is 1.4, blah, blah, blah. We look at this. Can we take the square root of this? No, the square root of 3 is not something nice. So we leave it, and this is our final answer. We broke up this bigger polynomial into separate pieces that we will, on the next page here, be able to solve. So there you go. So that's the first set of problems on your worksheet. It's going to be factoring, and there's more review. There's also factoring ones like we did yesterday as well on there, and these. The last thing is about solving. So here's where factoring comes in handy. Apologize for my voice here. This is where factoring comes in handy because we can't really solve this the way it is. We need to break it up into smaller pieces. So we do what we did yesterday with when there's 4 things. We draw a line down the middle and factor out the front and back. This is all review of yesterday. I know I'm going through this fast. If you need time to write it down, ask Mr. Olson, who's awesome, and you can pause the video or anything like that. Now we look at this. Can we break this up? No, it's there. Can we break this up? Can we do the square root of 4 and get a nice number? Yes, we can. So we got to break that up into separate pieces. Okay, here's our last step. What makes this equal 0? This parentheses. What makes that parentheses equal 0? What number do I put in here? Negative 2. That's an answer. What makes this parentheses right here 0? 2. What makes this parentheses 0? What do I add to 6 to get 0? Negative 6. Those are our 3 answers together. So that's an example of solving using factoring by grouping, which we talked about yesterday. Again, if you need more time, pause it, let someone know. Next example. First of all, we got to move everything to one side and write it in standard form so it's easier to deal with. Next, we got to take out anything we can. They can divide 2 by everything, and we can take out an x. Next, this is a lookalike. Oops, sorry, that's a squared. This is a lookalike quadratic, just like we did on the previous examples. So we got to factor that out. Again, x squared's the middle term, so that's going to go in front of both parentheses. And then we want two numbers that multiply to be 12, add to be negative 7. So we think through, multiply to be 12, add to be negative 7. 6 and 2, no. 4 and 3, yes. So we're going to do negative 4, and -3 equals 0. So that's all so far. This is just what we did on that front page. Now the new part here, oops, one more thing. We can factor out this middle one here. X plus 2, x minus 2. And we can't do the square root of 3, so we leave that one. Okay, up to here is what we did on the previous page. So I know this is a lot of work, but that's polynomials. I mean, we have an x to the fifth, so it's just going to be a lot of work. That's just a bigger polynomial. So we go through what makes everything 0. What makes this 0, this x, 0? That's an answer. What makes this thing, this parentheses 0? -2. That's an answer. What makes this 0? 2. That's an answer. What makes this 0? This is more complicated. So I'll write it up here to the side. Oops. We add the 3 over. Now, we remember, hopefully, to get rid of a squared, we do something called a square root. Now, I hope someone in the room is thinking to themselves, at least multiple people, when you do a square root, you need to do something special. You need to put a plus or minus in front of it. So those are our final answers. We have a plus square root of 3, a negative square root of 3, a 2, a -2, and a 0. Notice how many answers we have. 1, 2, 3, 4, 5 answers. Notice the highest exponent power, 5. Let's look at this one. We have 3 answers. Notice our highest exponent power. Usually, not always, usually the exponent power that's the highest, the degree, gives you the number of answers you'll have. So we had a 3 and a 3, we had a 5 and 5 answers here. So the higher the exponent power, the more complicated it gets, again, as I have already said multiple times, I think. So just so we're clear. Last one. Sorry if you're bored already. I apologize. Don't worry, it's only 11:30 then. Don't procrastinate, kids. Last one. Again, we got to get it to say equals 0, so we got to move it over. Our first step is always, can we take something out of here? I think to myself, I'm a smart guy. I know that 3 can divide both of those. I know they both have 3 p's. And we're left with this. Okay. Next step. This stays the way it is. Can we do the square root of this? Oh, that's a squared. Oh my gosh. Sorry. It's late. This is not. Okay. 4p minus 3. 4p plus 3. I can get this by doing the square root of this and the square root of the back end. And I split it up, and when we do the square root, we got to do plus or minus. So that's where the plus or minus comes from. It's from doing the square root of both of those. So now we go through and we solve each of these. What makes this p to the third 0? If we put in a 0. What makes this 0? We think to ourselves we'd have to add 3 and divide by 4. So that would be a positive 3/4. Think to ourselves for this one, we'd have to subtract 3 and then divide by 4. So -3/4. Those are our answers. And what I said before about the degree, the highest power being the number of answers, isn't always true, and I hope that's clear. This one has a degree of 5. We only had 3 answers. That's okay. But again, most of the time, the degree will give you the number of answers. It's just special cases like this one where there's multiple p's together like this. But at any rate, here you go. Here's the video. If you want to watch it again while you're doing your worksheet, or want to see an example, or didn't write anything down, I tweeted it out last night. Well, I don't know, in the future. I don't know. I'm gonna tweet it out. I'm gonna put it on YouTube and then tweet out a link as soon as I'm done. It's also on my YouTube. Remember that's youtube.com/Mr. Bidlin here. So look those up. It'll be called Section 5.4, Part 2, Solving. So if you're looking on YouTube, that's what it'll be. Otherwise, I'll be around right after school, and then I'll be around tomorrow morning and stuff as well, and all day during class tomorrow, too. So, but the rest of the time is yours. You got a lot of time. Use that wisely, and help each other. If you're struggling, ask someone around you. I'm sure they'll know what's going on. So, good luck, and we'll see you tomorrow. Thanks.